All right, everyone. Welcome to today's meeting. Today we will be talking about a whole lot of things. Since we're only meeting online today, I figure we'll go ahead and try to be a little bit more in depth with our meeting. So, as far as recaps go, we are still waiting on those airframes. Robbie has emailed the people to go ahead and try and get a tracking number from them of some sort, or to try to get an ETA from them, because I guess he got confirmation January 12th that it was sent, and they said it was going to be like 4 weeks. So I was kind of expecting it to come in next week by like the 11th or something. Still waiting on a CAD from Avionics and Recovery to see where their bulkhead placement and everything's going to be, to see if we need to screw anything, or not screw, put any holes in it for them. Eason machined one side of the motor block, which I showed you all the video for. The other side he's machining today. And then after that, he just needs to tap the 6 holes for the screws. So he should have that done within the next couple of weeks for us. And then, as I mentioned before, IA Coatings agreed to do the paint job after we drilled the holes. And this doesn't really apply today too much, but I will stop recording once we finish the meeting slides for meetings, and then talk about whatever more so pertains to something more lab time, like making decisions about things. That would just make the meeting too long. Okay, so for the boat tail, we have it reprinted now. I know last week I had mentioned that it was undersized. So now this is the size that we were needed to work with. The fiberglass sheets are now at the lab after resolving some confusion with shipping. The plan for next week is to take these pieces, go ahead and try to do the Bondo again to fill in the divots. They've already been sanded a little bit, and then we'll go ahead and sand down the Bondo after that dries. And then once I purchase the primer that we talked, that Jordan's been looking into, we'll go ahead and see if we need to come Saturday to do the priming, or how quickly that's going to set for us. And then also needing to finish purchasing the chopped fibers, and I'll just pick up some masonite that we can use as our parting board. Okay, and so for the centering rings, the CAD has been started for it. I know in the old one was just laser cut out of some wood. I don't know what kind of wood. Apparently there were 4 threaded inserts in it. But we can go ahead and confirm how many we need with Huang and Win. Since they've been looking at fasteners and everything, they can kind of help us determine that, so we have some justification. But we do need to kind of determine if things need to be stronger and made out of a better material than wood, or maybe a stronger kind of wood. So that's something we need to look into. As far as the Randy's MMM deal goes, I guess I forgot to update this slide, actually. This is the one slide I didn't update. We have kind of a rough CAD of it going on. Gustavo, since you won't be here the whole time, do you want to share your screen and just kind of show what you were throwing together?
Yeah, let me join through my iPad.
Okay. While he does that, Donald, go ahead and tell us about the carbon fiber a little bit.
Okay, so for the carbon fiber sheets, we had 2 choices to go with, either a plain weave or teal weave. These are the 2 most common choices as far as weaves go in the fiberglass sheets. The plain weave is symmetrical, high fabric stability, and has a lot less distortions, but only when you're working with 2D contours or flat surfaces or tubes. The twill weave, they're the most recognized, the most common, very high fabric stability, and also very suitable for complex contours. And when I think about what we're going to be doing with these sheets, the 2 is probably going to be what we're going to work with, most likely.
Just because the complex contours and everything that we're debating on doing.
Yeah, and it also has good fabric stability and also more affordable.
Okay, and then were you able to find any pricing for it?
I couldn't pinpoint an exact link yet because we still haven't like discussed the size that we're
Okay.
gonna need. Yeah. So
Not a problem. Gustavo, you're good to share your screen whenever you're set up.
Cool deal. It says I can't share my screen.
But no.
Okay. Ah. Okay, there we go. What was I gonna show? Hotel. Oh, the MMM design.
Yeah.
So we have this kind of thing is just like the lower assembly for the rocket. Just as hold on. Let me switch audio from.
That's better. Okay, now I don't have to hear myself twice. Okay, so we have the lower assembly. It's just a rough CAD. I put this together today just more as a visual than anything. And so we have the lower airframe that is here, right? Just this one. And why is one visible? Oh, okay. So the idea is we want a MMM, but not in the same way that an MMM was before, that we just kind of bolt fins on. The whole reasoning is that after talking to Randy about the whole MMM stuff and, you know, fin flutter and making sure that the fins are going to break off with the speeds we're going at, we kind of came to the conclusion that the only safe bet with the fin flutter and everything was going to an like a internal fin can / MMM design. And since then, Ravi and Analysis have gone through, and it looks like fin flutter shouldn't be too much of an issue. They're looking at some other thing that they've discovered, which is called like I'm not even going to try to say the term, but essentially there's another force that can rip the fins off at certain speeds. They're looking into that. Until then, I guess we still have to figure out the MMM design. After talking with Randy, the whole idea was that we wanted something that could hold the fins, I guess, a lot more securely than just an MMM that had like a bolt on the top of the fin, at the bottom of the fin. So the idea is that we can have something that's basically like this is going to be our MMM, and we could have multiple of these theoretically where we have different fins, and all we do is we load it into the rocket as a separate MMM. And so this is the a tube that would go around the motor casing. And well, yeah, you guys can see me. I got scared for a second. Can y'all say something just to make sure I'm not like speaking into oblivion?
You're good.
Okay, cool. We have this like tube, which is just going to be like something that goes around the motor casing, and attached to that we're going to have just the fins. And the way we would do that is with carbon fiber weave, or maybe even fiberglass weave. We would epoxy the fins to this tube and use the weave to kind of fill in do a fillet like on those edges, just to make it stiffer and make that connection really, really solid. So there's idea for that. And then the way we would interface that, just I guess rough sketch would be, we could have like a centering ring that's on the bottom of this that could interface with the boat right there. And then we'd have like slits in the boat tail where the fins go. And then all of this assembly with the motor inside, there's no motor right now, but with the motor inside, we'd slide that into the lower airframe as seen there. That's that.
What's the tube made of?
So, which one? This one? Sorry, this one?
The tube that we have epoxy the fence to. Yeah, that one.
This one?
Mm-hmm.
Yeah, this would be made out of fiberglass. It'd be the 4-inch section of fiberglass that's in the lab right now.
It's gonna be wrapped around the motor casing.
It wouldn't be wrapped around the motor casing. It just the motor casing slides into it.
Like a friction fit or like a loose fit.
I don't know exactly because hold on. The inside should be like 3.9 inches or something, and then the motor casing. Hold on. But I can tell you later. But right now, the idea is it would just be a fit. It's not like a super strong friction fit to where you'd have to push very hard, but it
Mhm.
wouldn't be like too much wobble, ideally.
Gotcha.
So I guess one option, I know that when we were talking about how are we gonna make sure that the fins are aligned properly, how we were thinking that might be a concern. But if we just directly attach the centering rings to the top and the bottom, we can just have those attached to the fins while we are.
No.
What are you doing? We can just have those attached to the fins while we're doing the sheets and everything, and that'll keep them aligned for us. We won't have to worry about like printing something to align them.
Yeah. What I was thinking is we could do something like this. Okay, that's massive. But the idea is we'll just get this and we would subtract the fins. And so that way, we have like something that just has fins cut out of it. It's hard to see, but the fins are cut out of it. And we could just 3D print that with like a hole that connects through. I don't know, that's not a very good example. But yeah.
Yeah, I think I see what you're saying.
Yeah, because the idea is we want something that holds them perfectly perpendicular to the thing, 90 degrees apart as we lay it up.
Okay.
But yeah, I'll
Well,
stop saying this
I
one.
hope that makes things more clear as far as the MMM goes, because I know it's kind of just been talked about and maybe like not the most clear. So I hope that cleared it up a little bit for most people. Can anyone confirm if that helped?
Well,
Okay. So I guess moving on. Oh, well, yeah, that's kind of why I had Donald looking into the sheets though, to see, what we would use to reinforce it if we went the carbon fiber route. Just because it is stronger and we're concerned about how stable it's going to be, depending on what the fin flutter stuff looks like. For fasteners, here's the document that they've started on. When you can go ahead and take it away.
Yeah, can you all hear me?
Yeah, we can hear you.
All right, cool. So I look into like two options, the rivet and the screw, because they are most like popular, very easy to put it on the whatever things that you wanna fasten them. So are you all familiar with rivet, right? So and screw, I'm pretty sure everyone knows, but do I need to explain what rivet is?
Go ahead
No?
and explain it, because I know we do have some freshmen who haven't been super familiar with
Okay.
things like shear force and rivets and things like that.
Okay, cool. I mean, it's just a quick description. So there's two rivet that's on my table, the plain rivet and the solid rivet. Plain rivet, it has cylindrical tube, and then it attacked to a round head, and then there's a mandrel that goes throughout the cylindrical tube. And then when you want to installate it, you need a punch hole, and then you use a riveter, which is a tool you're gonna punch the mandrel through the rivet, and using the compression forks, the mandrel head, it will push in the outer cylindrical tube, and then it will lock in the two sheets together. I should have a picture on here, but at work, so I just asked Haley to just put whatever I have on the document. Sorry. Moving on to the solid rivet, it's just a very much more simpler version. It's just a solid cylindrical tube with a round head on top. We also use compression forks to increase the diameter of the tube, and then it will lock in the two material together. This solid rivet is it requires the hammer and forgot the other one. What is that? Oh, the bucking bar. So you need like two pulls to actually create a compression fork. Screw, I'm pretty sure everybody familiar. Here I have three types of screw: flat head, pan head, and then cap screw. The difference is mostly about the tool that you're gonna use to lock in them. Pan and flat head screw, you tighten them with the screwdriver. But for the pan, I mean the cap screw, you're gonna use the Allen wrenches to lock in them. So that's just a quick introduction on the two that I'm looking into. And on the table, I listing like 5 different part numbers with the price, with their ultimate tensile load and ultimate shear load. The reason they are here is mostly because of the high value load capacity that these nuts can handle. I mean, these screw and rivet can handle. For now, I am not sure if I want to go for 6 or 8 screw or 6 or 8 rivet. I do need the input from I mean you or Gus, Haley. Show me the picture of all the component that gonna be made together using these fasteners. So it kind of give me a little bit better visualization on how many and how I gonna put the fasteners.
You said you need something like that?
Yeah, the pictures, like orientation of all the component that will be made together using these fastener. Does that make any sense? Just the pictures.
If you come to the lab next Friday, I can just show you most of it based on Oberon. So you can see like in person.
So we still don't have any model or anything that can.
Yeah, I have a CAD of some of the stuff. I just think it may be better to visualize some of it, since we do have an actual like reference to go based off of.
Okay. Yeah, because I want to keep the picture or something with me, so I can take a look at it without the need to go way until like next week or something for the lab.
Right now you're focusing on the motor block, right?
Right.
Okay.
If you have the like dimension or the weight, because I think I read the document that Gus sent me, the trace study on the fastener. They have the big velocity to calculate the accelerations, and from acceleration and mass, they calculate the force, and they derive the stress from force. So if I want to do something similar to that document, like the trace study, I do need some input from you, and I did write it in the work document I sent to you earlier. So if you can give me a little bit input on that, and also the picture, I'll be much appreciated for the motor block, at least for now.
Are you free at all after, I guess, tomorrow or Sunday?
Sunday maybe work. May
Yeah,
work for
if you
me.
want, we can hop in a meeting and then talk about it a little bit more.
Okay. Okay.
Anytime during
Uh,
our 2 to 5 reserved lab time.
Yeah, anytime is fine. And then go back to the pictures right here next to the table. It's just like me trying to visualize what happened in here. The force apply is something that I need to input from y'all, and then the FS is the shear force, and that will be just equivalent to the apply force. And from that FS, I can divide my area to get the average shear stress. And I'm gonna use that number and the load capacity of those fastener, and we'll compare them, and I can give you the safety factor. Yeah, so that's what my plan is so far. Anyone have questions? Anything that you can comment?
Does anyone have any like logistical questions as to like what is a shear force, how is it being calculated, or anything like that?
I mean, shear force is not something so special. I mean, the like the like equation that everyone know is F over A. Would be something we can use universally. Um, but there also there's a big assumption behind that equation is the stress is uniformly distributions. Then you can just use the ratio F over A for stress. But at least for me, I don't have like the FEA the stress analysis, so I don't know how the stress is distributed among the two components that I'm trying to make with the fastener. So I just carry that big assumption into the equation F over A and do the comparisons later on.
Well, I will
But
definitely go ahead and send over the stuff that we have for the motor block, and then you'll have a bit more reference
okay,
for that, and then whatever else Gustavo and you can talk about tomorrow.
yeah, thank you.
Thank you very much. All right,
No
so
problem.
justification document. Any of these folks, feel free to unmute, take it away.
I guess I can do it. So we put down a bunch of questions on the document. We need to organize it into the correct format and start answering some of the questions and giving the justifications. I also had an idea about doing a section before the components about the overall design and just talking about why we chose certain things and then splitting it up into components.
And then one thing that we'll talk more about at the end of the meeting is kind of setting some kind of deadlines, even if it's like multiple deadlines, just for like kind of reference as to like how y'all are keeping pace with everything. This applies to like everyone, not just y'all. I did look a little bit over the document, and it does seem like y'all really just like sat down and got a bunch of questions together, which is a great start. Exactly what we were kind of talking about to do. And then one thing that we'll also do at the end of today's meeting is kind of talk a bit about any of the justification that y'all aren't sure on. So we can look over the questions, and I can maybe answer some of the questions that we don't have, that y'all may not have the answers to. All right, Ben. Let's see if he was able to make it to the meeting. I know he said he might not. Okay. So as far as what Ben was looking into is he was just kind of seeing into what analysis was doing about the fins. This picture to the top right is kind of the design that analysis is thinking for fins right now. They would still be made out of the carbon fiber, and they're still kind of finalizing and looking into like more fin flutter calculations and other things that can influence it. But they're trying to finalize it by Sunday. So hopefully by then we will have a confirmed kind of fin that we're looking at, and then we can use that to base our MMM on. Jordan, I know it's just links, but you can talk a little bit about looking into everything.
Okay, so yeah, I was looking over some of the places to look for PVA film and chopped fibers today, and when out of all these links for the PVA film, the first one would be, I would say, the cheapest, and the second best would be ACP Components. And for chopped fibers, yeah, I accidentally looked up something for like milled fibers because I didn't know what type of fibers we were sticking with, but I found some chopped and one milled. But out of my search, I found that Tap Plastics has the cheaper cheaper product of chopped fibers for like a pound. It's like $14 compared to the one that you had from Amazon that was like 18. But no, yeah, this at most I just found that like fiberglass and Tap Plastics would be the best places to look for PVA film and chopped fibers.
And then as far as, did you look at all about shipping? Because sometimes that'll kind of make the difference
Right.
between.
Yeah, so I forgot to look at the shipping, but from my assumption, I'm guessing they'll still be like, well, yeah, depending on the company, they'll probably make the shipping all different. And yeah, so I would have to get back to you on that one.
So because I'm trying to get them sooner than later, if you get the chance, just by the end of the weekend, go ahead and just kind of update them a little bit. And then I can go ahead and make that purchase as soon as possible, because I also want something with a short lead time.
Do we have a BOM for this, or do you want me to just put the pricing on the slides?
On the slides, and then once we determine which one we want to purchase, then we can put it on the BOM.
All right, gotcha.
Thank you very much, Jordan. Okay, so overall for the assignments, I don't know what's supposed to be deleted. So I did delete some of the ones that are pretty much completed. I can go ahead and complete this one for Ben once analysis has completed all their stuff. And then we still need to do a little bit more as far as the CAD goes. Since we just have kind of a rough one right now, it's not, the end all be all. One thing that I do want to confirm is the material for the centering ring, which whoever does this, it would kind of go hand in hand with what Huang and Win are doing. So you would probably talk to them about it as well. So is anyone
Who's doing
interested?
that again?
Huh?
I'm sorry, I'm asking who's doing the centering?
Well, that's what I'm asking right now, is who wants to.
Oh, okay, all right.
Yeah, this would just be the material for the centering ring. And we would just kind of be determining if the wood that we used last time is suitable, or if we need to go something stronger, or if we just need to go ahead and like get it machined to fit for the purposes of what we're wanting. Any takers?
I can look into it.
That was Jordan?
Yes. And remind me again, who was doing the centering ring?
The CAD for it?
Or like, so I can like, get any more information if I have any questions. Or.
Oh, well, it's not machined yet.
Okay, sorry. I thought I heard someone saying that they were working on it.
So what they are working on, this top bullet, they're working on what kind of fasteners to use for like the motor block, and the motor block is going to be pretty similar to the centering rings. So once they have that down for the motor block, they'll probably be able to determine pretty easily the
Mhm.
fasteners for the centering ring, since
Okay.
it's essentially the same shape. But
So-
what you just kind of need to figure out is just what material is going to be suitable.
Mhm.
You don't have to do anything crazy, just kind of look into what kind of forces are going to be on it, and just kind of look into the strength of the materials.
Okay, and are we assuming that the centering ring and fasteners are going to be of the same material?
No.
No? Okay. Okay.
Let's see. And then as far as setting deadlines. So I know I've shown you all this document a couple meetings back as far as trying to keep our stuff all in one place for how long things are going to take. Right now, we kind of have this rough idea for the boat tail. Obviously, we didn't end up getting to do some of this stuff today because we had bad weather, because this was kind of the plan. But as you can see, I just kind of want to get a rough idea of when we can expect things to be done. So when it comes to, finalizing the design for the MMM, I think we kind of finalized that last week that we want to go with that design, but now we're needing to complete a CAD for it, which I kind of want to complete by the end of the weekend, having like a pretty good idea on a CAD of what we're wanting. And then we'll need to kind of figure out just all of these things. So I know that Ben said analysis is probably going to have their fin stuff by Monday. So just kind of trying to determine everything. We don't have to set all the deadlines right now. I just want you to know that these are where the deadlines are going to be. It would be nice if I could go back to my slides, but I can't click up. There we go. Okay. And then I can probably stop the meeting here because now I just kind of want to go over some of the questions and also a little bit of the justification document. So if anyone's watching the recording, ending here for that reason.